afternoon. Now we are going to learn about mostly mass balancing when it comes to fractional distillation. And here is our bare feed. That is the fermented wash. And the pump is now running, feeding the fermented wash to the towers. So from here, the mash, fermented mash, flows to the top beer heaters, and from there the purpose is to pick heat from that and get more preheated, so that you save on heat, which you are going to inject here. That is steam. And also it helps for faster stripping of alcohol from the fermented wash, so that it can run fast to the rectifying tower. Now here at the bottom, the towers are running both. The stripping tower, as you can see, the fermented wash enters from top, and here is where we balance our mash. And we have a pressure. We have a pressure gauge, which we normally gauge on the pressures of this tower, depending on the size and the amount of mash we are feeding, plus the temperatures. We have the temperature gauge as well. This is the radio type manual, and we have the RTD. So this one is an indicator which we use normally to follow. So here we normally follow them, but as operators, normally we like having two, so that when you're an operator, you can use the manual one in case the one which is digitally controlled fails. Normally they fail, so you need to train on both the indicators. And here we have our control valves. These two control valves you see here, we are yet to commission them, of which we are going to do. Normally control the plant automatically. And we have our steam header here, which we push steam. You can see that line. We push steam into those two towers at different temperatures. And we have a pressure regulator, pressure indicator for these control valves, and steam pressure indicator. And we have a pressure gauge, which will normally determine the amount of steam we are sending. And there is that manual steam valve. That is a steam valve which we normally use. And here we are heading to the top. But before I go to the top, we have improvised one of the condensers into a heat exchanger. The purpose is, whatever we are trying to do is to have heat economy. So we have that condenser there to preheat our fermented wash, because the vinasse, most people know it as vinasse or spent wash, as it moves out, it is at a higher temperature, that is around 100 degrees. And the fermented wash from fermenter, maximum can go up to 38. So we have to preheat it. By the time it enters the tower, it's around 80 degrees. It has picked all that heat before it enters, for us to be able to save on what? On steam and heat, and also to avoid losses. Remember, when you push in this material, when it's cold, there are higher chances that you are going to lose. Okay? Now, here we have our cooling tower. This does a great job. There should be two. One cooling the fermented wash, and another one should be cooling the condensers at the top. These condensers cool the alcohol vapors into condensed alcohol. which in turn comes back to the tower, and we draw it at a strength of, from the top it comes out when it is at 100 degrees. Then from the bottom, as it cools, it comes back to 96.2. So we are going to move on top, as step by step, as I show you whatever we do on this fractional distillation. Yes, normally while running, we normally tap off some impurities known as fusel oils. Some are high fusel oils and others are low fusel oils. So we normally tap off the impurities. As you can see, the stone is a bit high and we are tapping off the impurities. These impurities, those are the unwanted flavors, the unwanted smells, the fusel oils. Mostly when we are doing gins or other, let's say gins or packed whiskeys, you don't want to see any flavor in your spirit. Say the aldehydes, say the sulfides, mostly hydrogen sulfides, then mostly the fusel oils. Those ones smell so badly. They give a bad flavor in your alcohol. And here is where our vapor enters from, and you can see how it is boiling. Those are bubble cap trays on this tower, and it's doing quite well, the boiling. You can see it for yourself. Yeah. So we are going to the next step. So these are lines. You can see all these lines with valves are for cutting off the impurity. Those are fusel oils. Each and every tray you see here, we are going to cut off the fusel oils. As we now have this control valve, which is feeding, which we are yet to commission, but its work is to communicate to the pump, communicate to the flow meter, which you see up there, that if I need a certain fit, I need a certain fit to the tower, that is the stripping tower. This control valve operates by opening or closing depending on the amount of feed. If the amount of feed which is flowing up there, this flow meter communicates that the level is small, increase, then it opens. When the control valve opens, the wash flow increases. When it goes beyond, this one communicates to the control valve, the wash flow meter, that you a bit close, so it has to balance. And after there, we go to our product line. This is a product line. Now that line you're seeing there is our neutral spirit. We are drawing it at 500 liters. This is the current situation, maximum almost. We are drawing it at 500 liters per hour. And that is what is known as a safe and tester. That safe and tester, this work is where we normally tap off, connect and to the line to tap off a sample to check the quality of alcohol and the strength, if it is still in 100. So if I tapped off from this line and I check the strength of this, you will still find it in more than 100 alcohol contents. And these are vacuum breakers. They break the vacuum, this one and these ones. Yeah, you can decide to open or close depending on how you want to balance your draws and how fast you want it to flow. And these are the bypass systems. In case the safe and tester has got a problem, then you fix the bypass system. Remember, when we are running this plant, we have to make cuts of impurities. So when you're running and you're taking off this, you need to have at least a minimum of 5% of your cutoff. That is the technical alcohol which has more of the methanol, more of the, okay, low boilers. Let's say it has more of methanol, more of aldehydes, mostly when you're using molars and some sulfides. The sulfides you can easily smell in them. So we are going to see if this one is at 500. What's the rate at which we are taking off the what? What's the rate at which we are taking off the TA? Before I go far, as we are running, you can see each and every stage of where we are drawing from. We have temperature gauges and RTDs. These ones are indicators, direct indicators, which normally does well. But in case it fails, it means you have to get used, or your operators got to get used to these manual gauges as you wait for an engineer to repair your what? Your RTDs. Or then you can see here, this is our technical cut, technical alcohol, where we are doing our cuts. And you can see if we are there drawing around 500, we should be at least with a minimum of 20 liters. And if I bring it closer to you, you will see the stone is running at around 20 liters. So this in turn gives you a balanced what? A balanced draw. If I increase more, I may have issues with the strength on the other side. So normally it is a balanced win-win situation, whereby you need to calculate how much you are feeding in, how much you are taking off as cuts, and how much you have to draw, and stick to that so that you have a same wave draw, continuous draw. If you have a same continuous draw, the advantage is if your quality is good, that means you'll maintain that same quality, which is good with a good smell. So we are going to the next level to see. Yes. So the next level shows us the cooler. This is known as pipe-in, pipe-in cooler for our product. So alcohol enters from these lines, and as you can see, this is the water line, the red pipe. This one, as it goes, it enters from the side of the bigger pipe to cool. Purposely is to cool the alcohol so that it comes at when it is warm. Yes. Next level. This is the top of the alcohol stripping tower, known as analyzer tower, stripper or analyzer. And you can see the temperatures we are maintaining. That's around 95 degrees. And here is a wash inlet below, and this is a dehumidifier. Its work is to separate the vapor from the liquid. You know, when you're running a plant, normally at these temperatures, since it is under atmospheric, you expect carryover of the fermented wash, since we feed it from the top. So the carryover might flow to the rectifying tower, pre-rectifier, which is not good, and it spoils the quality and disturbs the plant parameters. And you can see here what we do here. We put this and have the vapors in a cyclone way, so that the vapors ascend to the top of that line you are seeing, and the liquid, because of its density, drops down, and there is that pipe which goes down and it comes back below that feed line. As you can see it, there is that pipe entering on the second pipe. You see it entering. Once it enters, that beer, the fermented wash, enters there, and again it is stripped off. So the vapors flow through that pipe into the rectifier at the bottom. There is our hot water receiver tank. This is the water which is coming from the condenser. Then it flows to flowing to the cooling tower, the other side, the other cooling tower, which I showed you earlier. And here we have what we call a degasifier, degasser. Its main work is to tap off, vent off the non-condensable gases. That is mostly carbon dioxide, and some aldehydes. Yes, that is its major work, only that. And it has its own operation parameters. So we are going to the next level. So that is the demystifier. So these are the vapors, they are flowing down. And here on the side, we have our lines. This is what you see there with the valve is a reflux line going, and it's going up to enter back into the tower. And this is another control valve. But the spirit we are going to draw from the tower is mainly controlled by the temperature of the fusel oil temperatures. So for you to have a better quality, you have to make sure that the fusel oil temperatures you're maintaining at the right correct temperatures. And for now, we haven't connected. That's why you see this bypass valve is open until we connect it and put it online. Yeah, you can see there are some leakages. These normally happen in plants because maybe the rubber gasket needs to be changed. The rubber gaskets needs to be changed. Quite good quality, neutral spirit. And that you see is a continuous of the degasser tower up to the top. And that is another vent tapping top where we normally tap the TA and it goes. This line you see there is coming from the vent condenser. Then we send to the other TA line. And here is the lines, the draw lines for the product. We normally draw from here and the product flows down. And these are the reflux line. These are the reflux pots which recover all the condensed alcohol from the condensers which we are going to see. And it all enters here, goes down, then comes, all enters from here. And here, this is the top, and you can see how it is boiling because it is a bubble cup. You could have a sieve, but the sieve could be, you could see only bubbles, some little liquid but with bubbling. But because this one was designed to the top with sieves, it means you're going to experience some liquid, which is not bad because the quality which is coming out is good. So we are heading to the top. As you can see, I'm heading on the ladders. And I think this is our topmost, and this is the top of the degasser. We yet connect it, and these are the beer heaters. As I had explained to you earlier, that the fermented wash first enters in these beer heaters, the ones you see here. Once it enters here, it goes to the second beer heater. From the second beer heater, then it flows to the other spent wash heater to recover heat. Because at this stage, it should come out when it is around 55, between 50 and 56 degree. You should have that delta T of at least 26. If you cannot make it at least 20, then when it flows down at 56 degree, it's going to carry another 26 degree from the bottom, or 30 whatsoever. And once it gets that 30, you can calculate you are at least around 80, between 70 something to 80 degree, which is quite good for whatever you're going to feed into your tower. And these beer heaters play a big role in the preventing losses, because you can't feed here water. The temperatures which are coming from the top of this RC are so high. The temperatures are high. Now you need a liquid which has a bit denser or with a higher specific gravity than the vapor, because the vapor flows a bit faster. So you need something which is a bit heavier to easily tap faster that heat. We could not use here water, and you could see the difference why we use here the fermented wash, and on the main and the vent condensers we are using what? We are using water. And you can see these two, one is the main and another one is the vent. So the vapors from the RC enters in the other beer heater, it comes to this one, then this vapor goes into the main. From the main also we have those sampling points for our reflux. Then from here it goes to the vent. This is the vent. Now the vent plays a big role here. You must maintain temperatures. You should be warm, and you should be in around something up to around 38 degrees Celsius. 38, that is the temperature, degrees Celsius to 42. Why? Because this helps you to vent off some of those non-condensable vapors, and the liquid is tapped and taken to the tower. Thank you, battery is cutting me off. Thank you, team. This is Leonard, Uganda.